we are going to cover today will be the first topic will be the importance of visualizations, right? So I'll be going through on why data science is very concerned about visualization techniques and why there is a careful way of doing visualization. Okay, and then we go through the basic visuals. You might be familiar with like bar chart, line chart, pie chart, okay, something like that. So I'm going through the basic visual and explaining the importance, maybe not really the importance, but what kind of message the basic visuals can relay to your audience. And then the third one would be redesigning the visual, the basic visual that you have that you're going to learn. So we are going to redesign it to make sure that your audience will actually understand your visuals. All right, and then the fourth topic will be the actionable visuals. It is to make sure that your visuals is something that can affect your audience, right? So the audience can take action about it. There's information on it, and as the audience, they know what to do about it, right? So the first topic, importance of visualizations, right? So when we are talking about data visualization, it's hard to escape or to evade from the point of telling storytelling itself, right? Because in every visual, there's always a story to tell. Right? There's no visual that's not telling anything. Even an artist, if it is not about data itself, even the artworks itself has a story behind it. There's no meaningless visual. If it is meaningless, then it's not really worth noticing. Okay. So the key point when we are talking about data storytelling and when we are talking about data storytelling, and we must touch on the visual key point. So the key question is, what do you want your audience to know? Okay, when you are presenting your visual, what kind of story would you like your audience to know about it? What kind of message would you like to deliver? All right, and then the second one, what do you want your audience to do? So let's say they already know what kind of information you wanted to deliver to them. They already received the information. So what now? What should they do with that kind of information? Okay, so these are the two main questions that you need to keep in mind when you are trying to design the visual. Okay, is to make sure your audience know what is the information and what should they do with that information. And then this is the sub question. It's not really a sub question. It's more like a precedent question after the second two, the first two. Okay, what technical errors you might? Okay, why we need to consider technical errors is because we need to be sure that the information that we would like to deliver is straight to the point and it's not bringing maybe a faulty information. Right? We need to make sure that the information we are going to deliver is as much as we intended it to be. Okay. And then if we are considering there is a technical error, what is the possibility that make it happen? Okay. When we are considering these three first questions, all right, when you empathize yourself as audience, you might know what kind of visual you would like to make. Okay, what kind of error that you might happen to make when you're trying to make your visual. Okay, please keep this in mind. So every time you make a visual, it's actually about what you like to present to your audience. So knowing your audience as much as your data is. Right? So visualizations can actually be used as some kind of a mining tool to get analytics, to get information from it, the visual itself. Or it can also be a way to project information right? The first one is to get information. From the audience perspective, it's about getting information, but from your storyteller perspective, let's say from my perspective, it's about storytelling. All right. And then what the best or the ideal case of visualization is to have both, right? So when we are projecting the information and you as the audience getting the information that is important, so we are creating a knowledge network, right? So basically, if I tell you information, you know the information, and then you are ready maybe to tell anyone else who in needs of those kind of information as well. So we are creating a knowledge network. This is the ideal case of why visualization is important in data science. Okay. So visual, like I said, mentioned previously, it must come with data and also with story. There's no visual that is standing alone by itself. It should bring some meaning on it. All right. This is how important visual is. It's almost as equal as having it important as having data, but it's less important than having a story. So basically, you need to, if there is a story, let's say there's an insight, you must focus on bringing the insight first before you start focusing on designing the visual, right? The visual comes after you have the story, the good story to deliver. So basically, to to visualize data and deliver a good knowledge, there is a three key points. Okay, the first one is to cater to specific data type. All right, because uh, to be real, there's like bunches of data types in the world, right? And if we are consider like business domains, there's finance, there is engineering, there is science, there's also social science. So there's a lot of data, there's a lot of data types, right? And each of these each of these data type has its own best visual to represent them, right? There's no one visual that fits them all. There's no, like, let's say a kit or a cheat sheet to tell us which visual will always make the best impression, right? So this is the one important thing that maybe you should consider when you try to visualize your data. Okay. And then the second one is simplicity. All right. People usually tends to make their visual kind of funky, kind of attractive in a way, right? But at the end, with those kind of design, too much colorful, too much colors, too much messiness, even though it doesn't make your audience bored, right? It's losing its meaning of delivering message, right? The message becoming a little bit noisy. It doesn't make sense maybe to some of your audience because the messiness makes your thinking process a little bit hard on encoding what the visual tells you. All right, that's why simplicity is actually the key in designing your vision, so it delivers the message to your audience, right? And then the third one would be interpretability, right? It's to make sure that your audience able to interpret the visual. All right. So when you are trying to make your visual, it is important to consider what kind of what kind of things that your audience are comfortable to look at. Okay. Sometimes you think, okay, I like red, so you design all your visuals in red, but actually your audience is not actually have maybe like kind of colorblind, so they don't see the difference between red or green. So you must consider this as well. This is the color blindness is just one example, a practical example that happens in the industry. It's a real case scenario, right? So this is what John W. Tukey said. The greatest value of a picture is when it forces us to notice what we never expected to see. All right. So if it takes you maybe several more minutes to explain what your visual is, it means that your visual, it might not be as good as you wanted it to be, right? If the visual can stand it alone, telling the story on its own, and with maybe a least explanation from you as a storyteller, that will be a good indication of a good visual. All right. So we'll proceed with basic visuals. Right. So I've already given you the idea of what a basic visual would be, but before we proceed, we are going through what kind of visuals. Like I said before, it's hard to escape data storytelling topic when we are talking about data visualization, right? So there are 6 main stories we could tell with our visualizations, with our visuals, right? The first one is distributions, and then we have proportions, we have relationship, we have comparison, and we also change over time, we have rankings, right? And out of the 6, there's actually the main 4. That's actually the like the basic 4, right? For example, when we are talking about rankings, it's actually a story about comparisons and also maybe a proportions as well. All right, where we are talking about change over time, it's also a comparison, or it might be a distribution, it might also be a relationship. So among these 6, there's actually these 4 main stories that you could tell. You could tell it's either about a distribution of your data. You could tell the proportions. Okay, let's say we have, okay, how many peoples are T20 or M40 in Malaysia. That's for example, right? Proportions. And then we have relationships. So we want, maybe we like to tell, we like to study or present whether the sales of ice cream may be affecting how many shark attacks happen in the ocean, right? It might be relational, it might be not, right? And there's also comparison. So basically, maybe let's say we are talking about fiscal year of profits. Maybe in 2020, there's a very downturn of events where profits getting less because of the COVID-19, right? And then 2021, we are seeing maybe we are predicting that it might be better than the previous year. All right, we are comparing between 2 categories. All right, and then we are talking about data visualization. All right, the important things is not about tools. All right, tools is just tools to make sure on how you can create your visual. Okay, it is not the important part of making a good visual. Okay, it depends on your proficiency with the tools. Okay, I think in this course, I believe in this course you are already exposed to RStudio, right? So if you are going to pursue data visualization with RStudio, you could go with ggplot2 application. Okay, it's a library in R. Okay, and then if you are proficient, let's say in Python, you might go with matplotlib. And then if you are more to a user ends, right? You are not very technical wise. You could go with Tableau or also Power BI. And then if maybe let's say you are proficient with Excel or JavaScript, another programming, or maybe as well as Adobe Illustrator, you might just go with it. Okay, there's no problem on how or what kind of tool you are using to create your visual. Okay. The important parts of visuals, like I said multiple times before, it's about stories and your audience. Okay. So the first one is bar chart. Okay. When we are talking about bar chart, we are using in Tableau context, we are using category, or what we could use as what we could also describe as dimension. And then there should be a numerical variable, what we call is as measure. Okay. So this is one example of bar chart. The important key in bar chart is to always have, it must share the same baseline, all right? And the most ideal, or maybe the most relevant baseline would be starting from 0. Starting from 0 is actually a critical baseline for any bar chart. Okay, you cannot start your bar chart from, maybe let's say you are skipping up to 100, up to 100, and then you are only presenting this part of bar chart. So in this case, you are actually mispresenting your data, all right? Because the importance of bar chart is the value is represented by the length of the bar. Okay, the length of the bar. So if you are trying to hide this length, all right, it brings a misconception on what the data tells you, the values. The values is kind of skewed, not really skewed. It's a fault. It's falsified, right? It's important to give your audience the right length of bar. All right, this is a critical point in bar chart. And bar chart can be derived, let's say, into a histogram, right? Because every bucket is actually a categorical representation of numerical bin. So it could be a histogram. And then maybe if you are familiar with a stack bar chart, right? There's also a bar chart, right? And let's say you are trying to display a multiple series of bar chart, all right? It is recommended for you to only present it maybe up to 4 series. Okay. Do you understand what is meant by series in a bar chart? May I know?
No, I don't.
Okay, so when we are talking about series, right? Series, let's say we have, okay, maybe I can use the example as well. All right. Okay, let's say we have this furniture category as a series, and then we have office supplies as another series, and then we have technology as another series, right? So if you look at this, I'm using an until up to 3 series, right? And maybe you are familiar when some people represent it something like this: furniture besides office supplies, and then besides technology, right? And then it will represent bookcase. And then there's another chest information. It's a repetition of another furniture, office supplies, and then technology. Okay, so that kind of subsection within your category is called a series, right? If you are familiar with Excel, every time you are trying to plot multiple columns, it will automatically create every column as its single or specific series. Is that clear, or do you need more description on it?
Thank you.
Awesome. So this is I'm going to show you how to program a basic bar chart, right? It's just a basic bar chart. Okay, so the first one would be just creating a canvas of it, right? But the canvas is already have a mapping on what kind of data they are going to take. Okay, so in this case, we are going to take a DAT variable, which is our sample superstore data set. All right, and then we try to create we are creating a column, a geom column, meaning a geometry _ column onto the canvas. So with the mapping, right? It knows that X is representing the discount column and Y representing the subcategory columns in the data set. Okay, so once we have our bar chart, I think this is it. Unless maybe if you recall our previous chart, right? We have like two categories or two level of categories, right? So we could also make this in R. Okay, but it will make maybe a little more extra of lines. This is it. We are going to utilize facet grid function.
Azhar, we are also recording this session, and the students will be able to access this after this, so they can actually try again, even if they have missed some parts. Yeah.
Okay, sure.
No problem.
So we got. I'm just going through casually. Okay.
Yeah.
There's
Okay.
no need to wait for them. Okay.
Yeah. Can.
All right. So I'm assuming you have done with this. The reason where I'm not going to explain each function of it is actually, like I said before, tools is not how we define our visual, right? I'm just giving this code for you to get an idea on how to use ggplot. Okay. When it comes in a real case scenario, all right, you might need to go through the ggplot documentation and take advantage on its full capability, all right, rather than making this basic chart. All right, so I'm going to continue with the second basic chart. It would be line chart. I guess you are already familiar with this as well. If you are creating any chart, maybe on Excel, line chart will be the default chart. If it's trying to understand your data, right? Because it can be numerical against numerical, or it could be numerical against date time. Okay, I guess it is impossible to represent numerical value versus categorical value. All right, because the meaning behind the line, the connection, the connectivity between lines is actually, it's showing the continuity between each x or each axis. All right. So if you are trying to make a line chart using a categorical variable as its x-axis, it doesn't really delivering the right message to your audience, right?
Right.
Oh, okay. Yeah, because there's no continuity or there's no connection between categorical. When we are talking about categorical values, we are talking about distinctive. We are talking about a value that is distinct. There's no maybe when we are talking about number 1, number 2, number 3, there should be no 1.1, there should be no 0.99. It's distinct. It's 1, it's 2. There's no in between them, right? That's why line chart is only possible when there is continuous measure. So there's only continuous values versus continuous values. Okay. And the most popular one people using line chart is when we are talking about change over time. All right. Let's say maybe if you are very active with cryptocurrency trading, right? Line chart is something that you are going to look at every day, right? Because it represents a change of, let's say, a buy and sell value. Okay, it presents the change. It is the change that gave you the anxiety or maybe the hype of what is going to happen maybe in the future. All right, this is the line chart power. It can predict. It is good in giving a predictive idea. All right, if let's say we are using a bar chart, it doesn't really give you that sense of a prediction. It only maybe give you an idea on how to classify, right, rather than to predict. Okay. Anyone need a description on maybe an advanced description on line chat, or would you like to maybe skip through the codes? Any question?
I have a question.
Yeah.
Hello.
Yes, yes.
For this line chart, we can only plot between two variables, not more than that.
Okay, that's a good question. When I'm talking about variable, it's not always about two exist variable, right? It could be another variable represented by a different way. It might not be a line, it could be maybe a different line. All right, there can be multiple lines on your chart. So this different line could represent your maybe your third variable as well. All right. But the ideal case, or maybe my suggestion would be to never use a 3D chart. Never use a 3D chart. So it is suggested to only use a 2D canvas chart. All right. This apply as well for bar chart as well. Okay. Always use a 2D chart rather than 3D. Okay. Any more question?
Is there any specific reason, Azhar, because of the 2D and 3D?
Okay, so the 3D chart actually mispresenting your data, right? Because with 3D, we are playing around with perspective, right? It is hard to perceive 3D perspective on your 2D screen. Do you get the idea? Right?
Yeah.
Maybe in someday in the future when we have hologram, maybe as some of our popular way of presenting data, maybe 3D visual could be some advantage on that phase, right? But at this moment, at this age, 3D chart is not recommended for you to use. Not even in marketing, right? Marketing is when we are using a 3D in marketing or maybe presenting to your audience, right? It might also lead to a legal problem as well later on, right? Because your 3D might not serve the right value to your maybe prospective customers. So your customer can sue you for not presenting the right information to them, right?
Yeah, agree.
That's why business is more concerned on using 2D data, 2D chart, right?
Okay, thank you.
All right. Any more question? I'm prompting more question because line chart is a common chart that most business is using. So maybe if you are interested to know more about it, that's why I'm prompting more question. If there is none, we can proceed with the codes. Okay, we are proceeding with the code. Okay. For this case, right? If you notice when we are using R, okay, are giving us the opportunity to manipulate the data first before we feed it into our canvas, right? Let's say if you are using Tableau or Power BI, right? The application of Tableau and Power BI can actually manage this kind of data manipulation internally, all right? But if you are using R, you have to take the control of manipulating the data first. Sorry, not manipulating, aggregating, calculating the data first before you feed it into your visual. Okay, so in this case, we are creating maybe another data frame called N records, and then this new data frame is fed into our canvas. And then this is to create the line. We have the canvas and we're giving them the line, the information. All right. Yeah, as simple as that. It's just that when we are using a programming language to visualize, you need to take a more control on the interaction between data and the visual, right? If you are using a user-friendly or maybe a user-friendly application like Tableau, maybe you don't have to worry much about it. Okay. And then the third basic chart will be a pie chart. Pie chart is very useful to show proportions to whole information. So basically, it's about comparing one part of you to the bigger parts, or maybe a bigger picture of the population, right? That is one example. But in most cases, right, actually a specialist in statistics doesn't recommend you to use pie chart as well, right? Because using pie chart, it's hard to compare between two or three values, especially when the value itself is not significant, right? Let's say from this perspective, right? Can you give me the answer between west and east? Which one is bigger? Who owns the majority?
I want to say west.
You want to say west?
East.
Yeah.
East. Okay.
West.
Okay,
West
west.
also.
West.
West.
Same.
West. Same. But there's also someone who is actually saying east, right? Because
Same.
there's because there's uncertainty to actually get the idea directly. So in this case, even though when I create a pie chart, right, I might need to maybe put in some labeling to give you the number value. Okay. But if I'm giving you the number value, so what is the meaning of me creating the pie chart? I'm just wasting ink on it rather than just giving you the numbers, right? So the visual is just something as aesthetic rather than a storytelling supportive things as supportive tools to guide the information. Okay, that's why a specialist in statistics doesn't actually recommend you to use a pie chart. But I know that most business actually very like pie chart. I don't know why, but we keep on advocating to not use a pie chart, right? Because of this mispresentation of visual. This is how we create a pie chart. It's more complicated than a bar chart and a line chart. It takes more codes to make it if you are using R. But if you are using Tableau, it's convenient as much as the others. Okay, so this is the basic. You can already see the pattern. When we are trying to make a canvas, we start with a ggplot function. And then on top of the canvas, we put in the information object. All right. So this is at this point, we are actually creating a bar chart. All right. And then from this bar chart, we are going to make it polar. Right. We are transforming it into a polar form. Hence giving you the idea of a pie chart, kind of like a pie chart. But it's actually a bar chart being bent to make it looks like a pie chart, right? So it's an extra step. So let's proceed with the last one. I think it is heat maps. All right. It seems very simple. It looks like a table, right? But it's actually more efficient in presenting proportions rather than giving a pie chart. Actually, this is a good example, a good alternative to a pie chart, a heat maps, right? Because color actually giving you more, people are more reactive to colors rather than to reading text. That's why giving them the colors and maybe some reference to what does the color means, you are getting the information more faster than reading the text. All right. It's probably more faster than looking at a bar chart as well, right? But it's not always the case lah. Okay. Heat maps. Okay. This is using Tableau. The one I'm showing you on screen is using Tableau. If using R, there's maybe a limited access to it. There's a limited option, limited manipulation, right? Okay, so you might not having the same design of which I have shown you. All right, so we have canvas. Even the canvas itself is a bit more complicated. Okay, and then we present the geom tile. And then because we know that when we are talking about profits, right, it's about good and bad. And then people normally associated good maybe with something like blue, and then they associate bad with something like maybe oranges or reddish, right? That's why even though the original geom tile function create a blue monochromatic blue heat map, but I decided to change it into blue and orange, right? When I am trying to convey a message about profit, right? Let's say if you are bringing this heat map of the same information maybe to Korea, to South Korea, right? South Korea maybe seeing red as a good things and blue as a bad things, just like they are seeing a stock coloring, a stock price line chart coloring, right? The blue means good, the red means bad, all right? So it's important to consider what kind of your audience preference, all right? And you need to make your chart convenient for them to understand. Okay, remember, interpretability matters. And then if you are not satisfied with only colors, you could still maybe add on the label as well, right? But it depends actually. If you are not talking about the comparison between each of them, right? Colors itself might be enough, right? There's no need to put in values in them. When we are putting values in them, we maybe we are giving this presentation to maybe a CEO, where the numbers also matters rather than the insights, the bigger idea. Okay. Yeah, so it's important to consider who is your audience is. Right? And then we have a scatter plot, right? But in your data set, the one that I shared with you, I've looked through it, and there's actually not really a good example to show you scatter plot, right? So what I'm using here is just a sample scatter plot picture, okay? So you cannot recreate the scatter plot using the data that I've shared with you. All right. But I'm giving you the hint here. If you are trying to make a scatter plot, you use geom point function. Okay. You could recall the standard practice before. We have the canvas function, and then plus the information or the plotting function, and then maybe some redesigning of it. Okay, so for scatterplot, it is geom point. Oh yeah, so scatterplot is good when we are talking about relationship, all right, and maybe a distribution information, distribution stories. So for in this case, maybe we would like to know how exactly a speed of a car affecting the distribution the car has traveled, right? So it makes, yeah.
I just want to interrupt for a while. I have a question from a student here.
Uh-huh.
Because it relates to the 3D question that you answered just now.
Okay.
The question is, are you talking about 3D? The 3D charts. Do you mean charts that have 3 axes, or charts with 2 axes represented in 3D?
Oh, okay. Okay. For that question, the answers would be the chart that has 3D visual, not a 3D dimension variable. It's okay to have a three variables or 3 dimensions of data, right? But it's not okay to have a 3D. All right. So you should present your data maybe as a square instead of a box. That's for example. I'm more talking about a 3D in the sense of visual. Okay.
Okay, thank you.
Anything else?
Yep, that's all so far.
Okay.
Thank you.
Okay, so back to the scatter plot example, right? So in this case, we are seeing a relationship between on how fast a car can go with how fast it was before the displacement was taken or the distance was taken, right? Even from this point of view, even there's no trend line, right? We could already see the trend line by maybe intuitively, right? So this is the power of scatter plot. It also gives you the idea of distribution, right? You can see some time of them, they are a bit, maybe not really a distribution, it's about a variance. Okay, so how many plot or how many data points actually differs from the others for the same x value. Okay, so any question before we proceed with the third topic?
Any
No?
questions?
Yeah.
No,
Any
no. So
questions?
far, I think we can continue.
Okay, so the third topic will be maybe it's not as important as the basic one, but it will be great if you have good skills of redesigning the visual. Okay, because like I mentioned before, the importance of visualization is always to deliver message to your audience. Okay, so having the leverage to redesign your visual to fit your audience preference and also your data types, that would be very, very helpful for you, right? So in redesigning your visual, you must consider who your audience. So you must build a profile of your audience. You must, not really you must, you could assume as well on how your audience would react to your visual, on what kind of visual do they like, what please them. Okay, you could build the profile about them. And then knowing them, you know what kind of story you can tell them. Okay, because let's say you are talking about a house, right? You are advertising a house to someone who is already owning a house and doesn't looking forward. So as an audience like that, he or she might not interested to know about your visual at all, because that's not kind of a story they wanted to know. Okay, so knowing the audience can lead you to choose the right stories for them. All right, and then the third one, consider how you can tell them this story. Okay, some people doesn't actually like too much color. Some people like very, very much color, right? But despite that, you still need to make sure that they get right, they get the right information, right? Even if you are using lots of color, you are still giving them the reference of maybe each color representing them. All right, like I said before, even if I'm using a rainbow color, red, green, yellow, blue, indigo, violet, all of that, right? So each color may be represented some meaning. Okay, so you don't use it randomly on your charts. There must be a meaning on it. Okay. So this is an example on the efficiency of a visual, right? When we are talking about the efficiency, position or scatter plot will be the most efficient way to give information, right? And then we have a length, a bar chart, and then we have a line chart where angle matter, right? And then pie chart represented by area, and then we have a heat map and intensity, and then we have a stack bar chart, or maybe represented by color or shape, right? Yeah, I think it makes sense why colors and shape is at the least efficient, because there's no way to actually associate, let's say, shape to a value of a number, right? There's no continuity. So it's hard to tell whether is circle meaning bigger value, is a triangle meaning a lower value. There's no such thing to represent value to them. All right. but we usually use shape maybe to represent the categorical difference. Okay, when we are talking about blood A, we are using a dot, and then we are talking about blood B, blood type B, we are using triangle, and then we are talking about blood type O, we are using as a rectangle. Okay, in that kind of sense, yes, it's just giving them the categorical difference or series difference. Okay, and this efficiency ranking was made by McGill and Cleveland in 1964. All right. So I need to remind you that it is always important to consider your data, always consider your data and consider your audience, right? So it doesn't matter what McGill and Cleveland have found. If you have found otherwise for your audience and your data, all right, I suggest you to follow the right design for it, okay, instead of depending on these tips, right? But most of the cases, yeah, these tips actually the best way to present your data is. All right, there's your question. No. Okay, yeah, and then when we are trying to make a changes, there's no actually a good coach or the best coach to show you an example for that, right? The best way when you are taking a leverage on making the right graphics or right visuals is to understand the documentations of your tools. Okay, you need to know what kind of function is best for your cases. Maybe there's an example, you need to make a chart on something, and then maybe you can ask on Stack Overflow on how to do it. The important thing is you have the idea on how to do it, and then you can look out for it on how maybe your R Studio could create the same code. Getting you the same code to create the visual that you wanted it to be. All right, so reading a documentation is actually a soft skill, a good soft skill as well in this digital age. All right, so among of the advanced way of redesigning your visual is to create a filters. All right, only focus on the data that you like to show only, rather than vomiting all the data that you have. All right, focus on the one that your audience care. Okay, focus on the one that the data is very precious to be looked at. All right, and then the second one would be sorting. Okay, in some cases you are trying to show maybe like a ranking, right? So maybe some people are just concerned about who ranks the most, who ranks at the bottoms. So if you're giving them the sorting, if you sort your visual beforehand, right? It gives audience the convenience of reading and getting the information they wanted. Okay. And we have labels. All right. This is similar to filters, but sometimes filters is just we are removing the data that we don't want them to look at, right? But in the case of labels, there is maybe important points that we would like to show, and then the maybe the surrounding or the population is still as much as important to get the idea of the context, right? So that's why labeling is important. Maybe we could label only the important parts of the data, or sorry, the visuals. And we could also add annotations to give you the idea. All right. Sometimes the visual itself might not be able to talk by itself, right? Because there's some complications. Some annotation could help them. Okay. Let's say if you are never been in this world where COVID-19 doesn't happen, and then you are looking at the data in a world where there's COVID-19, so annotation might give your imaginary audience on what happened in 2020. All right, you could say in 2020, COVID-19 breaks out, right? That's one of the example of using annotations. So it's useful to give the information of presenting the visual to people who is not in your field of study or maybe in your domain business. Highlights. It's similar to labels. Sometimes we don't want to misregard or disregard other information, right? But instead of misregard, we only want you to focus more on some some strips of information. For this example, we want them to focus on the second class of delivery, all right, a shipping of second class rather than the others. Maybe you are in a department where you are handling second class, right? That's why you are concerned more about second class, but still you wanted to more you need to know about the context of the others shipment, right? You have a formatting, right? Because the originals, let's say if you get back to the original, let's say the original R chart, right? It's not very neat, right? There's some things that is not important for your audience to know, all right? So you can go to formatting your axis to make sure the canvas is clean. You can, let's say, change the way you can present your value. Instead of 1000K, too much of a zero, you could use kilo to present the thousands. You could present in months rather than in weeks. All right. Anything that is much better to be understood by your audience. Make sure it is processable by your brain, your audience brains. All right. Don't overload them with too much of information. And then we have a reference line. It's similar to labeling in a way, but it's giving you maybe an idea on how each population is different by the others population, or a sample between samples, right? In this case, on how central, east, southwest is different in average and median. All right. But regardless, we still need to know the profits of every year. Yeah. So the last topic we would go into on making, not really to be reminded that your visual should be actionable, meaning that your audience could take action on it, right? Rather than just viewing it and know nothing about it. All right. So there's 4 direction of messages. We could have a strategy, it convey high level data, and we have analytics. So you allow your audience to interact with your visual, and we have operational. Okay, let's say the dashboard on your cars, right? That's kind of a visual, operational visual. So it gives you the idea of it's a live visual where you could take action immediately. Then there's also it's just giving you information without knowing your audience what to do. And the best way to maybe to combine several visuals or to deliver the right message is using dashboard. All right, because sometimes one visual might not be able to deliver your message. All right, you might need several of them. So how would you like to design your visual to be presented, maybe in a story or maybe in a compiled dashboard, to make sure that each of them have a continuity of a good story to tell your audience, right? There's a connection between them. It's just not just because you vomit the visual on the canvas. There must be the right insights for them to know. Okay, I think we have reached the end of the session. All right. And I received a request from Dr. Sri Devi that you might need a project to be done, right? For you to get your degrees. So I've gone through a writing by Jeanette M. Wing, right? It's quite latest on September 2020. She was listing the possible challenge areas in data science, right? So I'm going to show you what kind of challenge. You could also go to the original reporting for you to get the better idea. Okay, but I'm sharing you the basic one. Okay, the first area would be a scientific understanding of learning. Okay, the scientific understanding of learning may be like say a machine learning, deep learning. Okay, of how useful it has been. Okay, how useful deep learning and machine learning has been. Actually, the theoretical understanding behind it is still quite vague. Okay, people still don't know how actually deep learning works. Okay, it creates a good result, but they don't know why it can create a good result. Okay, so you could do a project on understanding it on this topic, and then we have a causal reasoning. Causal reasoning in data science is about getting the right effect, the right, sorry, not right effect, right factor. Let's say if you are using a data in a financial banking, right? Sometimes banking create a risk factor for the customers, whether this customer, maybe we could loan them some money or how much money we could lend them. Okay, so they have some their intuitive reasoning, right? But with so much data we have now, right, we could actually study which factor is actually affecting the delinquency of your customer, of the customer. All right, and then precious data. All right, you could go into a project where you find out what kind of variable is very, very precious in your business domain. All right, let's say you are working in an engineering background, right? It is important to have a logging of sensors in your factory. So your precious data is modeling on how to set up those sensors in that kind of environment in your factory. All right. So you could, you could define what kind of data is useful to be collected. And then the fourth one will be multiple heterogeneous data sources. Right. There's abundance of data in the world right now. Realistically, we have no idea which data source is very useful to you. Right? That's why it is good to understand which data source is important and actually how to combine them together, to integrate them together. Let's say I have a data from Kaggle, and then I also have a data from my own company, right? There's some data, there's some gaps between them that I need to connect so that I can make maybe a more predictive model, a machine learning model. So how should I do that? How should I connect between these two different data sources? All right. And then this is the fifth one, inferring from noisy or incomplete data, right? I think this is the most popular one if you are getting an interview for a data professionals interview. Yeah, they will always asking you, how do you handle noisy or incomplete data? Right, there's a missing value. How do you clean it? How do you handle it? Right, and actually there's no right way right now. No one knows the right way. People need to understand their business knowledge and they're trying to figure it out. So if you are interested in making a project on it, maybe specifically on your particular business domain, let's say you are working on finance, so you could study on the finance data and try to create some model on how to handle noisy and incomplete data in your system. Okay. And then trustworthy AI, privacy and ethics, it's more about a social and trustiness, all right? Because there's so much data so much data around us, all right? Some people are very worried that their information is going to expose, all right? So how do you make sure that this kind of data governing around you is kept properly only to the right authority? Okay, this is the trustworthy AI, privacy and ethics concerns about. Okay, it could be your projects as well. I'm not sure if you are interested with technical or social study, but these three parts would be best if you are interested with maybe social engagement study on data science. All right. And then the last two, computing system for data intensive applications and automating front end stages of data life cycles. It's more to a computer science background. All right. So you have a lot of data. So how would you handle your computer, your machine, to be able to compute that's bunches of data, right? How to make it more efficient to process it? What is the best method or procedure or the best algorithm to make it happen? All right. And then automating front end stages of data lifecycle is to actually making the cleaning, the messing up, the noisy and incomplete data just automated, right? You could also go into this project to make sure that maybe in your university data, you like to the computer to solve it for you, to clean up the data itself without you taking maybe some 2 days, 3 days, maybe a week just to clean the data. Okay. Do you have any question? I think we have reached the end of the session.
Yes, I have one question. Actually,
Yeah,
two.
please. Okay.
What are the difference between precious data and just your normal data, and how do I know if the data is precious?
Yeah, that's actually a good way to start your project, actually. This is the key area of how do you define a precious data. The definition itself is actually not really clear. That's why data scientists are very concerned on how actually to define precious data itself. And then let's say when you are, if you are more specific into your business domain, let's say you are an astrophysicist, so you could study, maybe you could define what kind of data is important for you, right? Let's say you are concerned about luminosity of the stars rather than how big the stars is, right? So it depends on the project. The precious data, it depends on what kind of analytics you are concerned about. That might be a naive way to define precious data, but it is how we define it now, unfortunately.
Thank you.
What's your second question?
I have a question, Mr. Azhar.
Okay, yeah, sure.
Okay, I come from engineering background and I've never used much of Tableau or Power BI. Would you
Okay.
say Tableau and Power BI are something that you can self-learn?
Can self-learn? Actually, yes, it can be self-learn because the Tableau, the application provider itself, like Microsoft and Tableau, they actually provide a certification of uh, a learning course for you to enroll. Even CADS from ourselves, we also provide a learning opportunity for you. Okay. But if you are talking about self-learn in a way, in a sense, it is free, I don't think so unless you have a game to achieve. Sorry, not a game, and a goal to achieve. Okay, let's say you have the idea what kind of a story would you like to explore. So you could start with that story and then you build your skills from there, from basic to basic, explore the features around it. Then yes, right? And to be frank, when I was embarking into the journey with Tableau, I was actually self-learning it. I tried it around rather than I'm looking into the documentation. I'm looking into the community discussion.
Okay, thank you.
Any more questions?
Any more questions? So, Azhar, we already reached the end of your slides, is it?
Yeah.
Okay, all right. So, any more questions? You want to share, you ask anything related to data science or anything from, I mean, it's good that you, yeah, data visual. Since you all are doing your group project now, anything that concerns that as well, you can ask if it relates to data visual.
Mm-hmm.
Yeah.
So if you are presenting your visual of your project, right? Who is your audience? Might be. Your
Most of them,
lecturers?
most of them actually using like it's like more like a case study. They are using most of the data taken from Kaggle. So it
Uh-huh.
depends on what is the domain. So they are coming up with their problem statements, the objective
Ah,
to achieve, and their target audience. So basically, I believe from your presentation, the data visualization should be based on their domain and what is their goal at the end,
yes,
right?
exactly. I'm pleased to hear that. Because some people actually very not really some people, most people I've encountered before, they are very very focused on making every visual fitting every data they have, right, instead of focusing on what kind of domain they are in.
Yeah.
So yeah, so I'm pleased to hear that you are actually acknowledge that domain is important to know about.
Yeah, I mean, I do agree because I think it's not that the graphs are there so we can just plot any graph that we like, right?
Yes,
At the
yes,
end of the day, what, it's just like statistics, right? What test you want to do or
yes,
what graphic you want to use, you should have a justification for that. That means you want to achieve something by plotting that, right?
yes,
Yeah.
exactly.
Yeah, so I believe, I mean, that's what I hope the students are going to do. That I mean, when you are plotting something, you have a reason why you plot using that particular visualization
Yes,
compared to the other. Yeah,
yes. It's not about a fashion show.
yeah, true,
I mean,
true.
fashion show might have a reason as well. I'm not sure.
Yeah. Any questions, guys? Any questions you want to ask?
One question here.
Yeah.
Yes,
So okay, I found out that there are loads or tons of visualization packages in Python. For example, like the famous one are like Matplotlib and also Seaborn. But there are also a lot more others visualization packages that could simplify for example the way you want to do EDA, exploratory data analysis, that could
yes.
for example um simplify or summarize EDA into a like one or two line of code. So how do you, as a someone who starting to get into data science, right? How do we pick and or choose our visualization packages in the right way?
So okay. So if I'm a
Because there are too
beginner,
much, just too much packages available out there.
too
Yeah.
much packages. Okay. So if I'm a beginner, my choice will be to ask the popular opinions. Actually, yeah, because the popular opinions usually come from people who has experience and they know which one is simpler for them, right? So you get the idea on how what kind of trouble they have encountered, what kind of convenience they like about the applications. So you could ask them what is their suggestion, and you could also embark to the same journey as theirs, right? But be reminded that their easiness might not be your easiness as well. All right. So there's no way for me to choose which application to start. But maybe I can add some. If you are a user and right, you are not very proficient with technical, you could embark with Tableau or Power BI. They are more user friendly if it's considering only visualization. And then you can left maybe the integration of the ICT everything to your ICT department if you are working, right? You could focus only the visualization itself on the application. Does that answers? Or are you interested with Python particularly?
Yeah, for some projects I'm using Python as my language. Uh,
Okay,
so
so for Python, uh, I heard you said Seaborn and Matplotlib, right? So you could use
yeah, those are
Seaborn
the famous ones. Yeah.
because they are more convenient. Seaborn is mentioned as convenience because you could start a basic chart with it, and then you could use Matplotlib to leverage the full capability of your visual. All right, because Seaborn doesn't allow you to make uh, maybe advanced modification, but Matplotlib has a lot of it. That's why Matplotlib, even though it is not as user friendly as it is, but it's popular among data professionals, is because they have the capability to make their ideas happen.
And it's still relevant up until today, right? Okay.
Yes, it is still relevant because both of the packages now is it's open source and people keep on maintaining it.
Okay, okay, understand. Thanks.
Yeah.
Very good questions. Any more? Maybe we can take one more. One last one. Because it's already prayer time as well, right? I think I can hear the azan. Okay. Anyway, any more questions? One more? Last one? Okay. So I believe, yeah. So I think we end our talk here, Jazaha.
Yeah.
Right. So firstly, thank you very much. Thank you so much for your time, and in fact for considering whatever that I have discussed with you, and you try to put all of them together. You know, including discussing about the possible projects and all.
Yeah.
I believe it was a good discussion between the students and you, and also even I learned a lot of stuff today listening to your talk. Thank you so much. And I also would like to thank Miss Husna. Also, I call her as Cheryl. Cheryl, if you are here, thank you so much for arranging it. My point of connection with CADS actually. So she's always so helpful. Thank you so much, Husna. And thanks again. Hi. Thank you so much.